very happy that AWS can join us on these workshops, because Cloud9 just makes things so much easier. I don't know if you've done workshops before where you spend maybe half of the workshop getting everyone's environment into the same setup, you know, who's on Windows, who's on Mac, who's on Linux, what do you have installed, what dependencies do you have installed. You know, Cloud9 gives us a great common IDE where we know we're all in the same situation. So if I share my screen right now, you'll see that I've been following along with Michael's instructions as well. So I have my ID here. I got my event engine account. So I'm doing exactly the same on this workshop as everyone else, starting with a fresh environment. Because I am a little bit behind, I haven't run a couple of the commands, but that's absolutely fine. And as always, everything we're doing here is viewable from the AWS Workshop webpage. I'm just going to move my Zoom sharing bar out of the way so it doesn't bug me for the next couple of hours. There we go. So yeah, if you want to go to bridgecrew.awsworkshop.io, again, this is not going away after the workshop. If you want to go back through any of this afterwards, the AWS team are kindly going to leave these accounts running for a good kind of 12 hours or so after this workshop. So if you want to kind of skip a section or take notes or go, hey, I'd actually like to rerun through that later on, you'll be able to come back to this workshop at any time. This is permanently live, and even the AWS accounts are going to stick around for a little while. So hopefully that gives you all time to play with this and things like that. So what we're basically at is quick setup. And these are just tools, as Michael said, that are really useful for things we're going to be doing later in the workshop. So giving you guys a quick sec to catch up if anyone's still behind. I'm just going to quickly install JQ, and then I'm going to install Python. And the reason we're going to install Python in our pipenv is because the local tools we're going to demo inside Cloud9, so the most basic kind of, I'm a developer, how do I scan my infrastructure as code for security issues, is our open source tool called Checkoff, and that's actually written in Python. So we're going to create a Python environment just so that we can install Checkoff. So once that's done, let's get straight on to the Bridgecrew setup. So for those of you that haven't created a Bridgecrew account, we are going to be using the Bridgecrew platform, which does all kinds of really cool stuff in terms of automated security scanning, runtime scanning, drift detection, automated commenting on your pull requests for any security issues found. And we'll go into all of that through this workshop. So you will need to go to the bridgecrew.cloud and create a free account. Now you can create an account by either authenticating through your GitHub or Google account, or you can click sign up down at the bottom via a work email address. So I've already done that step. I've already created myself a new account signed into an email address, and what I will get is this getting started page. When you sign up via email, you're going to get a welcome link for Bridgecrew with a one-time password, and it's going to ask you to change that password, which I've already done. So go ahead and do that. And then once we have the Bridgecrew account, we can carry on with the workshop. Just going to give everyone 30 seconds or so to put their email address in while I grab a little coffee, which is slightly colder than I wanted it to be. But anyway, once you have put your email address in there, you know, the email for the temporary password will be on the way. Let's go ahead and install the actual tools we're going to be using in Cloud9. So I already mentioned Checkoff, which is our open source local security scanner, which ties into the platform, as we'll see. So we can go ahead and really easily install that with pip3 install Checkoff. You can also install that in your own environments for future reference with Brew if you're on a Mac, or Chocolatey if you're on Windows. And then the final tool we're going to install is another open source tool from Bridgecrew called Your. Your is a really clever automated tagging tool for infrastructure as code. So if you've ever struggled with, hey, which tags do I need to add to my resources so that when they get deployed, I can track them or I can associate them back to a team or anything like that, Your is designed to solve that problem. And we'll have a look how that kind of ties into the overall security picture a little bit later on. And so we can run checkoff --help to see if checkoff's installed successfully, which it is. And then we can also run Your to make sure we have installed Your from those commands we copied and pasted. So I'm just going to quickly bring up the chat here, make sure everyone's on the same page. Just in your comment, Michael. Exactly. Who doesn't love managing complex dependencies? Yeah, so once we're at this point, we're ready to jump into the workshop. That's all of the kind of prereqs done. Again, so much easier doing that when we're all starting from the same place through a new AWS account and Cloud9. So thanks again to Michael and team for that. So we're now going to jump into module 4. And before we do that, I'm going to just take a step back. And for those joining us maybe for the first time, to kind of get an introduction to DevSecOps and kind of all things infrastructure as code security, I'm going to give a little bit of context. So first of all, we are running through a CloudFormation workshop. And what is CloudFormation? And for those that aren't familiar, CloudFormation is an infrastructure as code framework. So it's a way of describing specifically AWS resources as code. And the reason we want to do that is, as good and full featured as the AWS console is, let me open a new window here. As good and full featured as the AWS console is, with all the services and everything you can kind of see in the UI, realistically, if we want automated deployments, if we want to know exactly who changed what, when, how, and why, our infrastructure as code representation gives us that control and ability, which having multiple developers and multiple admins and multiple users clicking around in the UI does not. So generally speaking, what we find is people are adopting infrastructure as code through automation to allow them to more easily and repeatably manage their infrastructure. So what you can see here, and don't worry, all the CloudFormation we're going to be using today is already pre-written for us because we care more about the security of it and detecting misconfigurations than actually writing it from scratch. But you can see here a sample piece of CloudFormation that, with some metadata like a description, very clearly defines this section here, an S3 bucket. So we are creating an Amazon S3 bucket. We are giving it public read access. We're configuring the S3 website abilities within the bucket. And we're saying that, okay, yeah, this is the index page, this is the error page. So a very, very simple resource, which if we then ran that CloudFormation against our AWS account, it would automate the creation of that bucket. And we can name it and do all kinds of things with it. So with that said, what on earth is DevSecOps? And by all means, read this block of text at your leisure. But traditionally, what we find is when teams adopt, the technical back end of the DevOps movement, which is, automating everything through CI, making sure that your developers can push code, and pushing code triggers testing and deploying to production and things like that. When teams start moving quickly, which they need to, right, through automation, doing more with less, we generally find that security, I'm just going to quickly check. Can everyone still hear me okay?
Yep, I can hear you, Matt.
Perfect. Wonderful, thank you. What we find is that traditionally security is left out. So we might be using CloudFormation to automate our deployments. We might have this really slick scenario where a developer pushes some code, it runs all their tests, it creates them their AWS resources, it pushes that deployment to production. So you could wipe your AWS account, and yet rerunning CI would give you your entire working stack back. But we find that security was historically still a manual process, like a manual loop outside of that automation. And the problem with that is if you have a manual step anywhere in that automation, you're not getting the value of that automation. You can only run and deploy as quickly as the slowest part in your deployment pipeline. And if you have a manual part of that pipeline, then obviously you're still going to be putting demand on a security team for every time you want to deploy. But the great thing with infrastructure as code, this goes for CloudFormation or Terraform or Kubernetes or Helm charts, etc. Is we actually have everything declared there as to what we want our infrastructure to look like. So we are in a position where we can allow automation to scan the security posture of the infrastructure before we even deploy it. So in doing that, we can get to a position where we ease the burden on manual security teams, and we can have the security teams focusing on kind of other compliance issue rather than just kind of checks and balances on what we're deploying to our cloud. And that's what we're talking about when we say DevSecOps. We're talking about having the security part automated into the pipeline, just like our developer tests, just like our production deployments. And so this whole workshop is going to be designed to show you how Bridgecrew makes that easy for developers. Like if you're in a position where you're like, yeah, I want me some of that DevSecOps, like how do I enable this within my team? Where do I start? Please do ask questions. We are happy to veer wildly off onto tangents because they're always the most fun conversations. And yeah, hopefully this will give you a really good taster as to how you would implement security within your pipelines. So we're going to start super simple, and we're going to start looking at, okay, well, if I have some CloudFormation, if I have some infrastructure as code, what is the most simple way I can get a grasp on the security posture of that code base? And to do that, we're going to introduce a piece of CloudFormation that we've purposely created called CloudFormationgoat. Now, CloudFormationgoat, despite the funny name, and those familiar with other kind of security test code bases, I don't know where it actually came from, but they're all generally known as goats. CloudFormationgoat is CloudFormation written to be as purposely vulnerable as possible. So you would never, ever want this deployed into your Amazon account. But we have written a bunch of CloudFormation with just as many bad decisions as we could think of. So we have, secret keys accidentally stored in code committed in GitHub. We have public S3 buckets. We have unencrypted block volumes aplenty on our EC2 instances. Just, open firewall rules on, inbound load balancers and things like that. We have all kinds of really bad configuration, which would fail if you tried to kind of validate this deployment against, PCI DSS, CIS security benchmarks, kind of anything trying to suggest a secure way of doing things. CFNgoat is the opposite. And again, just because we do have other workshops and we know that not everyone uses CloudFormation, we have a similar Goat project called TerraGoat, which does exactly the same for intentionally vulnerable Terraform. And if you do want to see the Terraform side as well, do check out our Terraform workshop with one of my colleagues coming up in the next month or so. So CFNgoat is vulnerable CloudFormation. Anyone can use it, and that's what we're going to do. So we are going to go back to our workshop. And what we're going to do is in our Cloud9 environment, we are going to, oh, by the way, there's a little copy logo here if you don't want to keep selecting the whole text. So we can copy that, and I'm just going to reopen my Cloud9 environment because for some reason it disconnected. And you'll see, even though I disconnected, I'm exactly back to where I was with all my shell history and everything, which is awesome. And we are basically going to create a copy into our local CLI, our local environment here, of the TerraGoat repo. So, sorry, the CFNGoat repo. So you can see I have some CloudFormation here and here. And we've now got that from Git, and we've cloned that into our local environment. And then we are simply going to scan that against Checkoff. So to do that, we are going to run Checkoff against, and you can do this one of two ways. So if we just want a really simple check, we can just take the first checkoff-f CFNGoat, and what that's telling Checkoff to do is, hey, I have this file full of infrastructure as code. Open it and tell me if there's any security issues within it. And Checkoff's going to go and parse that CloudFormation. It's going to understand all the different resources of CloudFormation within that. And as you can see, we're going to get a load of output basically showing us security issues, which resource, which line numbers within our CloudFormation, and which file we need to care about. And this is going to help us understand the security posture of our infrastructure as code. So in its simplest form, this is how you can use Checkoff to get a really good idea as to the security posture of your infrastructure as code. And for each of these failed checks, we provide a help document. And you can think of this as like a virtual security advocate on your team. So you can go in here, you can see the severity, you can get some information as to, hey, why is this an issue? Why is this flagging up as a problem? And it allows you to kind of understand a little bit more about why Checkoff is highlighting these things. Now that's all well and good. You can see that we also scan for secrets, and we're like, hey, you shouldn't have secret keys in your infrastructure as code. They should be kept in a separate secret store. That's all well and good, but realistically, in terms of automation, which is the aim of the game, you're not really going to want to keep manually digging through this kind of text like this. You're not going to manually want to run Checkoff -f, or you can actually do Checkoff -d and scan a whole set of subdirectories for infrastructure as code, and that will work in exactly the same way. But it's tedious. It's an extra command that a developer is going to have to run as part of their pipeline. So we don't want to do that. What we can instead do is configure Checkoff to work with Bridgecrew. And Bridgecrew is the platform we've just signed up for an account, and it gives us a much nicer view and way of managing all of the data sources we're going to see of everywhere these misconfigurations can come from. So your code base, your runtime, your CI/CD pipeline, and we can manage that all in a single place with the Bridgecrew platform. And so the way we do that is by telling the Checkoff tool what our API key is to integrate with Bridgecrew. So what we'll need to do is we'll need to go into our Bridgecrew account that we signed up for and got the temporary email password for. Please do let someone in the chat know if you haven't got an account or you're struggling to sign up or anything. We don't bite, and there's so many of us behind the scenes here to help. So please do shout on the chat if there's any issue at all, or I need to talk louder, or I need to slow down, all is good. So what we're going to do is create an API key so that we can link Checkoff to the platform. So if we go to integrations and we go to the top right, there's an API tokens button. And what we can do here is create a new API key, which allows automation to access our Bridgecrew account. So I'm just going to call this Checkoff CLI key. You can call it whatever you want. And what's going to happen there is it's going to create us a API key. And we're going to copy that. And I'm actually going to store this in a file just by clicking plus new file and paste that up there for future reference. Please use your own API key, not mine. Otherwise, all your data will appear in this test Bridgecrew account of mine, not in yours, which won't be as fun for you. And then what we can do is we can start running this with our checkoff command. So if I take this checkoff command here, and I always forget to click the copy button. I don't know if anyone else is the same. If I take this command here, you can see that we have your BC API key as a variable here. So you can either delete that and replace it with the API key directly, or we can just create a variable called your BC API key, like that, so that this command will read it in. So if we copy this command, go in here. So what this is going to do is exactly the same as it did when we got the output. We're still going to get the output on the console, which is really useful for logs in like a CI/CD environment. But what it's also going to do is send all of those results to the Bridgecrew platform. Now, if I go and look while that's running at the Bridgecrew platform, and we go to the dashboard, because we've created a new account, we can see it's empty. If I go to incidents, we can see it's empty. We just have nothing really going on here. Whereas once we have run that command, and it does take a little longer because it's sending all of the data and it's asking the platform for any custom policies that you may have defined and things like that. But usually this would be running in your CI/CD pipeline. So it's not like a developer's kind of running this locally and waiting on it. So once that runs, we'll start to see things populate in the environment. And just while we're waiting, so that we don't waste time, we'll come back to these results later. You can see here an example of what we're looking for. So we will see all of those issues that were kind of in black and white text on the command line, suddenly now really nicely organized, all the resources categorized by the check, and we can filter on severity and benchmarks and all kinds of good stuff. Hey, Michael, did you have a question?
Yeah, I had a quick question. You mentioned custom policies. Could you go a little bit into that? So if I'm either on the security team or there's some extra checks that I want to run that maybe aren't on or aren't in the standard checks in Checkoff, is that something I can do?
Yeah, 100%. So Checkoff has a load of built-in checks, and we'll just kind of demonstrate that here. That is taking way too long to run, by the way. So I'm just going to kill that and try again. But in the meantime, I'm going to open up another terminal. Oh, there we go. Hey, if it's pausing for as long as it was the first time, you saw that that was way, way quicker the second time I ran it. There's no problem with running Checkoff as often as you want. So if it was pausing like it was for me, don't know why, but just hit it again, because that was taking an inordinate amount of time. And you can see, I'll come back to that question on custom policies in a sec, Michael, but you can see we get exactly the same output. The only difference is at the bottom of this, we now get a URL for more details. So developers can click that. It will open into the Bridgecrew platform, and it will take you straight to a page in projects where you can see the exact checkoff run that you just ran in the CLI, but annotated in a much nicer way, with much more easily visual pointers. And also that will have populated our incidents page with all of those as well. So you can see here, CFNGoat YAML, which is what we scanned. If there's multiple resources in CloudFormation, we categorize them. So you only have one policy here, and you can click and see all of the affected resources. And also the guidelines are built into here as well. So you don't have to open a link to go to those guidelines. And as I said, you can then filter on, let's just say we care about critical and high issues. and then we'll just see that list of critical and high issues so we can prioritize things we need to fix. Where are these policies coming from, to Michael's point? So Checkoff and indeed the Bridgecrew platform have a load of policies built in. So if you go into policies, you'll see there are a constantly increasing number of policies. We have over 1,000 policies now, and you'll see most of them are created by Bridgecrew, which cover everything from AWS, Google Cloud, Azure, pick your favorite cloud, but also serverless framework checks, Helm charts, Kubernetes charts. We support scanning a lot of different infrastructure as code, and you can see all the checks here, all prioritized by severity, and all related to different parts of a cloud infrastructure such as IAM. Now, if there are, I'm just going to double check that question there. Cool. If you and your business has requirements that don't fit everyone, so for example, most businesses, as a simple example, have a specific tagging policy. Something needs to be tagged in a certain way. Otherwise, if it doesn't have like a team tag on it, it shouldn't be allowed to be deployed. So if you want to use tags in that way, for example, that's not a policy that we can build into the platform for everyone, because one size doesn't fit all. So we actually allow a custom policy writer. And what you can do here is either create it in kind of this WYSIWYG solution here. So we can say, okay, this is a high severity CloudFormation, and we can start, as you can see, building this policy here in terms of what it looks like. And then we can say, is it related to any benchmarks? No. And then we can start defining a definition. So let's say I care about the API gateway. I care that there is a tag, and I care that the tag equals team. And what that's basically going to do is it's going to, oh, let me see what I've done here. And you can see we can do logic here. We can do or, and we can do and we can do all that kind of stuff. And what we're going to see is once I've created that policy, we end up with a single custom policy. And this is now going to check for any API gateway, that doesn't have that team tag. That's now going to flag up this test issue in our incidents, just like it would for any of the built-in policies. It's also worth noting that there is a policy language, so you can share these and develop them and save them in Git, for example. And we actually do support like having a Git repo, a third-party Git repo that you might run as your company, and we can pull those policies out of that Git repo and into Checkoff. And also, if you're using the API integration into Checkoff, like we've just done, Checkoff will pull down any custom policies you have in the platform and also use them. So it's a really good place for centralizing any of your custom policies. So with that said, we can now see that we have managed to populate Bridgecrew with a really easy way of kind of seeing our issues and understanding some of the issues we have. Now, this is great for a security team or potentially a security advocate on a group of teams that's trying to prioritize issues, but not every developer is going to want to see a security dashboard like this with the issues in the infrastructure as code. So we also surface this in more developer-friendly ways, so through pull request automation, which we'll see in a moment. But also, before I move on to automation and CI/CD, I also wanted to quickly draw attention to, and you don't have to follow along with this bit, but for those of you using an IDE such as VS Code or IntelliJ, we also support automation directly into VS Code itself. So locally, I've checked out CFNGoat on my local machine where I'm running VS Code. And as we can see, if I open a piece of CloudFormation, you can see down here we've got the Checkoff plugin integrated, and what that's doing, it's just updating itself at the moment, but we'll come back to that. It's going to automatically scan with the same policies everything that you just saw in the CLI and in the Bridgecrew platform, and it's going to annotate these automatically so that developers, even when they are literally writing the CloudFormation or the Terraform for the first time, they are getting pointers as to, hey, this isn't going to pass checkoff, this isn't going to get through CI, here are the issues with the security that you need to look at. But we'll come back when Checkoff's finished updating itself. That's just bad timing. So let us see where we're at with the workshop. So you can see, again, if you want to run through this later on, you can see we have screenshots of the output you should be seeing. We've kind of looked at policies from a creation point of view, but if you only care about certain policies, you can either skip certain policies or even just say, I only want to test for certain policies in the first place. So if we try running Checkoff, for example, with just those 2 checks, it will only show us any results for those AWS 55 and 56, and it won't give us the massive amount of output for any other checks. So you can see we're only running, we've only found 12 failures rather than hundreds of failures because we're only doing those 2 checks. So for more things you can do with Checkoff, --help, and for all the built-in Checkoff options, you can do --list, and you'll see all of the policies that Checkoff currently supports. So we're up to 1,637 built-in policies, and that's increasing all the time. And then we've gone on to look at the VS Code extension. Let's just double check on that. Still updating. I'm just going to restart VS Code here. And come back to that in a moment. But yes, so the VS Code plugin, super useful for giving developers that kind of first contact visualization. And then we've said that we can view the results in Bridgecrew, and that's a much nicer, neater way, especially when most infrastructure as code bases have kind of so many issues we find out of the box, that kind of being able to see it in this format and track it over time, especially with the projects view here, where you can take a specific point in time, you know, this was this time and date when Checkoff ran against this repo. That's super, super useful. So that's all well and good. We find that, you know, if someone was to ask me, what would I recommend in terms of kind of understanding my security posture when it comes to infrastructure as code, even just that, tying Checkoff into the Bridgecrew platform, super, super useful. Gives you, you know, suddenly for the first time, maybe an idea as to what things aren't passing, you know, regular security posture and regular kind of security objectives. But again, the whole point of this is automating security, so we can allow our security team or the security advocate on our team. Sometimes companies don't have a dedicated security team, so it's down to kind of, you know, more security savvy developers or operations people on a team taking that function. We want to free up their time to do other things, so let's automate as much as we can. So what we're going to do here is we're going to use AWS's CodeBuild and Code Pipeline, so AWS's CI/CD tooling, to basically automate running Checkoff and getting results into Bridgecrew every time anyone updates a code base, and the code base we're going to use is CFNGoat. Now, we are going to want you guys and girls to make changes to that code base as part of this workshop. And you can't do that on the CFNgoat you've cloned because that's owned by Bridgecrew, that's our master copy. So what we're going to do is we're going to create each of us our own fork of CFNgoat so that we can integrate our own version of it and make our own changes and things like that. So the first thing we need to do is go to CFNgoat in GitHub. So follow that link. And at the top here, top right, you will see a fork button. And if you click that and choose your GitHub account, that will create a copy of that repo directly into your personal Git account. So my Git username is MetaHertz, and you can see I've now got a copy of the CFNgoat. That's all we need to do with that for now. And now we're ready to set up our automated pipeline. So I don't want anyone to close down Cloud9 because we will be using this to run commands and save some files through this. But you will need access to the AWS console. So back in Event Engine, if you click the Open AWS console link, you may have to refresh the dashboard, the Event Engine dashboard, but clicking that will give you a new tab with access to AWS instead of closing down the Cloud9 console. I'm just going to clean my environment up a little bit here, just so I've not got as many tabs. And so what we're going to do is we're going to build a CodeBuild pipeline, and we're going to tie that into a, sorry, we're going to create a CodeBuild pipeline, and we're going to tie that into something called CodePipeline. And the reason there is two tools in AWS is think of CodeBuild as running the commands you want to run. So it might be your CI/CD tests, your integration tests, your unit tests, you know, the things you'd usually run in a pipeline. Think of it as things like Checkoff or security tools that we're going to be adding to our pipeline. So CodeBuild allows us to create little build steps for, you know, getting data from a Git repo, doing something with it, such as Checkoff and Bridgecrew, and, you know, failing or succeeding. And then CodePipeline gives us the flexibility of kicking those build steps off in, you know, a billion different ways, depending on what your use case is. So instead of CodeBuild only working when it sees a new commit to a Git repo, for example, CodePipeline allows us to trigger that build on, and I'm sure Michael will give me 1,000 more examples, but it allows us to trigger on not only kind of Git changes in source code, but maybe a new item pushed into an Amazon SNS queue or SQS queue. You know, there's so many, or an event coming from, you know, a system log or something like that. I'm sure you can help me with a few more examples there, Michael.
Yeah, I don't have a ton more examples, but like being able to trigger on specific branches or on certain actions, kind of tying into other sources like GitHub or Bitbucket, and doing that overall management of getting stuff from source, running whatever build tool you're using, running your test tools, and then deploying. So CodePipeline is that overall making sure we're doing these independent steps, whereas CodeBuild is going to be that that build and test side of things. So CodePipeline can work with Bitbucket, GitHub, code commit, all that fun stuff, and it can deploy to different services. It can manage deployments to different services, and it can use CodeBuild for building and testing, or Jenkins, or the other tools that you're using. So CodePipeline is that kind of pipeline and automating the process, whereas CodeBuild is the specific, okay, we're gonna running these build commands, and then we're running these test commands. So yeah.
Thanks very much. Yeah, so that's why it's split in two. And I think that kind of causes some people a bit of confusion, because when we're setting this up, it kind of looks like we're building two CI pipelines, but that's how they tie into each other. It just gives us more flexibility. So what we're going to do in CodeBuild is create a new CI pipeline. Now, obviously, in a real world environment, you'd probably be adding Checkoff and Bridgecrew to your existing pipeline. But because we're in a new environment, let's just start from scratch. Maybe you're not familiar with automating CI/CD pipelines at all. So let's go through the whole thing. It's just as quick. So we will create a new CodeBuild pipeline, and all the information you need to follow along is in the workshop. So for those of you catching up, we're currently at 5.2 AWS CodeBuild setup. And what we're going to do is we're going to create a CodeBuild pipeline. And this CodeBuild pipeline is going to integrate with Bridgecrew so that every time we change our CFNGoat repo, Bridgecrew gets the latest security information. So before we do that, we need to tell Bridgecrew we are wanting to integrate with the pipeline we're about to create. And Bridgecrew is going to spit us out some content, which makes creating our pipeline super easy. So if we go back into Bridgecrew and we go into integrations, pretty much everything you do to tie things in to the Bridgecrew platform from other sources comes from the integrations page. You'll already see it's realized we have a Checkoff integration from when we ran the Checkoff command with the API key earlier. And it also shows us the last time that that version of Checkoff reported into us and the repo that we were scanning. So we can click add integration. And because we want to integrate AWS CodeBuild, we just select AWS CodeBuild. Now, what that's going to do is it's going to ask us to create a new API key. Obviously, we don't want to use the same API key for everything. So because we might want to revoke access to certain things in future. So we can go ahead and create a CodeBuild API key, just give it a sensible name so we can find it later. And we create that. And again, that's going to give us a key. So we can copy that if we want, just because it's quite useful, maybe for debugging or to keep safe. I am going to seem to be having a little bit of internet connectivity issue with my browser because it keeps dropping my Cloud9 environment. I'm sure none of you will be having the same issue because it's the first time it's happened to me. So I'm just going to keep refreshing. Let's just write this down as well, that's our CodeBuild API key for Bridgecrew. There we go. And you'll see that what we're going to do if we click next is Bridgecrew is going to give us some commands to run against our AWS environment. So this is using the AWS CLI to basically put this API key into a secure variable within AWS System Manager. And the reason we do that is we don't put API keys in source code, in our CI/CD pipeline code. We keep secrets separate and secret. So usually we'd have to go and configure the AWS CLI. Locally, we'd have to get the keys from here for your account and configure and install the AWS CLI. But by using Cloud9, that's already done for us. So in here, you'll find that I can just run an AWS command, and it's already going to be configured with access keys for the account that I'm running Cloud9 within. So if I go ahead and do this, I can just copy and paste that command, and we get a successful result back from AWS saying it stored that key for us. So in future, CodeBuild will be able to get that key from System Manager, which saves us having to put that key in clear text in our CodeBuild pipeline, which, as I'm sure a lot of you are aware, kind of software supply chain attacks on CI/CD pipelines are kind of becoming more and more commonplace. And it's just good security posture to not store secrets and passwords in the CI/CD itself. So we'll put that key into Systems Manager, and we will go back to our instructions. So if we go back to Bridgecrew and click next, it's then basically going to give us the entire pipeline configuration we need to integrate Checkoff and therefore Bridgecrew into our CI/CD pipeline. So all we do is copy that, and we can either leave this open or you can paste it into a new file so that you have it handy like that. But you can see that this is configuring a CodeBuild pipeline, and you can see that it's requesting the API key from the AWS parameter store here. So BC API key, and then you'll notice we called it BC API key here. So that's how it finds the key. So we can click done on that if you copied it. If not, leave that open. And we can then go back to CodeBuild. And everything we need in terms of what we should call things, you can call these things whatever you want. But if you want it to be consistent when we start clicking around later, it's probably worth calling everything consistently with what I'm calling it. So here we go. We create a new CodeBuild project. I'm calling it Bridgecrew tutorial. Optional description. And then what we want to do is tell CodeBuild that this code repo that we want to scan is coming from GitHub. As you can see, we can support pulling from a load of different source controls, but our CFNGoat clone is in GitHub. So we'll click GitHub there, and we'll click connect using OAuth, and we'll click this big shiny connect to GitHub button. And it's going to ask us to confirm that we want to connect CodeBuild to our GitHub account so we can access that code base. And we click confirm. And then in a second, it says you are connected via GitHub. Now, I've connected CodeBuild to GitHub before. If you haven't, you will probably see pop-ups like this that we have in the workshop documentation, just having where GitHub is like, hey, are you sure you want to do this? This is what it'll have access to. And you can go ahead and click accept to give the AWS kind of CodeBuild suite access to the repo. So once we've done that, we can say, I want to use a repository in my GitHub account. And at that point, I can just search for CFNGoat, and it will find all the repos in my account that I have access to. And you can see that MetaHurt CFNGoat shows up there, and I can select that. So it should look like this at this point, and it has the path to our repo. And then again, just following the instructions, environment. And this is basically asking what kind of virtual machine do we want to run our CI pipeline on? It has to run somewhere. So we're saying Ubuntu standard 4.0, because that's the version of the Ubuntu image within CodeBuild that we've tested this workshop against. So Ubuntu standard 4.0. And then we can move down to the build spec section. Now, the build spec section is basically saying, okay, what do you want this pipeline to do? And there's two ways of doing this. You can either put the configuration of what the pipeline should do into your code base, so in the Git repo itself, which is generally the most common way to do this. And it's the way I'd recommend for production CI pipelines, so that you have a documented version controlled view of your CI pipeline, which is also why you shouldn't be storing secrets in it, because it might be in a public Git repo. But for now, we can also just say, hey, we're not making a very complex pipeline. We're literally just running the checkoff snippet that the Bridgecrew dashboard has given us. So we can also insert those build commands directly into the pipeline through insert build commands. So we'll do that, and we'll click switch to editor. And that's going to give us a sample template for a CodeBuild pipeline configuration. We can delete all of that, and we can simply replace it with the snippet that we were given by the Bridgecrew integration page earlier. So I'm going to copy that, and I'm just going to paste that straight into the editor like that. And at that point, we're done. We can click create build project. And what's going to happen here is we're now going to have a piece of automation that whenever we click start build, it will run Bridgecrew and Checkoff for us against whatever the current version of the code is in our fork of CFNGoat. Now, if I click start build right now, and you can, it makes no difference. If you want to follow along, then that's great. But I am telling you this will fail. And the reason this will fail is To upload the data to Bridgecrew, we need that API key that we stored in Systems Manager within AWS. The problem with that is, by default, AWS doesn't give one service any permissions to any other services. So the next page, 5.3, is, okay, how do we give CodeBuild permission to access our API key? And if you're building anything securely in AWS, like, you're gonna need to get familiar with this, which is why we haven't automated this for you. AWS IAM permissions are kind of the keys to your kingdom, and you need to understand how you enable access to things like secrets in a secure way. So what we're going to do is CodeBuild runs with its own IAM policy. It's a policy defining what CodeBuild can and cannot access. So all we need to do is add permissions to that policy to say, actually, this instance of CodeBuild should be able to access this one secret in Systems Manager. And so we do that through the 5.3. And what we can do is just go to, you see here, it failed because, and if we look, access denied, the user that's running CodeBuild cannot get parameters to our API key. So we need to fix that. So we go to IAM. And by the way, the search bar at the top of the dashboard is so useful for finding the services you need. It's such an improvement. And in here, we go to policies. And if we search for the policy created by CodeBuild, so I'm just going to search CodeBuild. And you can see there is a CodeBuild policy for our Bridgecrew tutorial. So it was created automatically by CodeBuild. So we can click into that. And we can see what it has access to already. It can write CloudWatch logs because that's where the output of CodeBuild goes. It has access to CodeBuild itself, obviously, and it might store artifacts in S3 from the build. So that's why it has those policies. Now, what we need at this point is to add extra permissions to this policy. And what we want to do is create an inline policy, basically. So give me a sec. My apology. I've got myself confused. While there is a policy, the policy is consumed by a role. And the thing we actually want to edit is the role. Again, I'm just going to close myself a few tabs down here because it's getting a little bit crazy. So what we actually want is roles. And my apologies, everyone. And if we again search for CodeBuild, we're going to find CodeBuild Bridgecrew tutorial role. And this is the thing that's consuming that CodeBuild policy. You can see there. But we want to add an extra policy allowing access to System Manager. So we can click Add Inline Policy. And then from here, what do we want to access? We want to access System Manager. And what do we want to be able to do? Well, the error message told us what was trying to happen, but it's also in the documentation. So if we go down, you can see we want to enable get parameters and get parameter. So you can type to find these, get key, get parameter, get parameters. Great. So we're giving this role permission to access parameters in System Manager. But obviously, the System Manager might contain thousands of secrets for thousands of teams. So least permission possible. We want to only give access to a specific secret, which is our API key. Now, to do that, we need to specify the Amazon kind of resource name for our key. And you can either do that by specifying the region and account and the name, or we can run a little command in Cloud9 to find out the ARN of that key we created earlier. So if we run this CLI command back in our Cloud9 environment, going to spit us out. Oh, bit of a typo there. BC-API-key. I'm going to copy and paste that into the chat for anyone that wants to copy it. And it's going to give us a load of information about that secret. And it's also going to give us the Amazon ARN of that secret. So we can literally just copy that, paste it into IAM here. Oh, add ARN, paste it in. And it fills that in for us. So we can click add. And at that point, we can click review policy. We can give the policy a name, again, following the instructions. I'm calling it allow CodeBuild access to Bridgecrew secret because I have, I like really long names that are descriptive and have no sense of humor. So there we go. And I can click create policy. And so what we now have is not only the original policy, but also access to the CodeBuild secret. So if we now go back to CodeBuild, and we click into our CodeBuild pipeline and we click start build, this will now be able to access the secret, and we will see a new integration in Bridgecrew with the results from the scan when this pipeline has run. So while we're waiting for that to run, let's automate this with code pipeline so that we don't have to click this start build button, because that's just as annoying as running the checkoff command locally. We want this to happen every time automatically when a developer makes a change to our Git repo. So to do that, we can go back to code pipeline, which again, as I said, is a different AWS tool or service, I should say. And following along with the instructions on page 5.4, we create a code pipeline to automatically trigger the build. So we click create pipeline. And again, this is just following the instructions so that everything's consistent in the naming. New service role, leave the role name alone. And then again, we need to integrate this with a source provider. And the reason we're doing this a second time is because the CodeBuild just needs to use GitHub to pull the code down from our repo. With code pipeline, it needs to use GitHub to get a webhook so that GitHub can notify code pipeline as an event every time there is a change. So we'll do GitHub version 2 as per the instructions, and then we can click connect to GitHub. We give the connection a name. So, oh, where's my tab gone here? Pipeline GitHub Bridgecrew, name that whatever you want, it's fine. And then what you'll see here is another prompt from GitHub saying, are you sure you want to do this? I'm like, yes, that's fine. You might get another couple of yes or no's if you have not done this before, but you will eventually get back to this page. And you can see all the screenshots are here as well. And then we install the new pipeline app, and this app sits inside GitHub and gives code pipeline all the access it needs to receive those events. So I'm doing this from my account. You can either give it access to all repos or only specific repos. I'm just going to do all repos for the sake of it. And at this point, it's going to want my Git password. So I'm going to move this off the screen and just quickly do that separately. Do we have any more questions, Mike Little, while I'm finding my GitHub credentials and hopefully not displaying them all over the screen?
Not off the top of my head. There's no extra ones in chat either. Yeah,
Awesome.
so I do have a bit of a question. So we've set up CodeBuild, and we're setting up this code pipeline to kind of manage it, and assuming that like there will be some tasks after it. So we're running the checkoff checks to make sure everything looks good, and then we'll do all of the infrastructure deployment later on. Are there ways to for Checkoff to block our deployments based off of certain policies? Maybe I really care about the high and critical, but I'm less concerned about the lows and mediums. Is there a way to kind of make it ignore certain ones, put emphasis on other ones?
Yeah, 100%. So as you can imagine, the skip check options in Checkoff, you can have as many of those as you want. We kind of showed how you could say, hey, only trigger on like these specific checks. You can also write a Checkoff config file, which you store in your Git repo, which is a lot easier to configure than Checkoff, and Checkoff will automatically find that if it's running in CI or if it's running locally. If you have a config file within the repo you're scanning, where you can specify a load of your own custom business logic on what you want to care about and what you don't. By default, when you are integrating Checkoff into a CI pipeline like we're doing now, Checkoff will automatically fail the pipeline on any check that you haven't suppressed. And you can suppress specific checks within the code itself. And I'll show an example of that in just a moment, so that not only will Checkoff skip that check, but you also have a history in Git within your source control itself as to who added this suppression, why are we suppressing that check? For example, hey, there's a business reason that this S3 bucket needs to be public. This was signed off by this person on this day, and that's stored in Git with your code base as well. So trying to be as developer centric as possible, so that there's no like hidden security settings somewhere else that developers might not know about. It's all kind of within the code and all happening within the pipeline.
Cool. So as a developer, I can manage it in my general source control system as I would be doing normally. I don't have to reach out somewhere else and find a small little thing and check an extra box. Perfect.
Yeah, exactly.
Awesome. Thank you.
No worries. So if we click connect now, oh, sorry, go for it.
No, I said otherwise, I don't think we have any extra questions in the chat. So continue onwards.
Awesome. Thank you so much. And we do have plenty of time. So if you do have any questions, if anyone's stuck, please do raise a hand. We're all here to help. As I said, if you are at the point where you're like, this is way too much, I just want to watch and kind of understand and learn, the entire workshop and also the AWS accounts that you're using, thanks to Michael and his team, will be sticking around for at least kind of 12 hours after this. So you'll have plenty of time to kind of go back through it, retest bits, play with, other bits of code pipeline if you wish, and all that kind of good stuff. So once we have our code pipeline connected to Git, which we can see, we have this nice big green indicator here. We can then select our repo. And again, we can do that by just looking what repos we have access to, because pipeline now has a connection to our Git. So they're all there popping up. So if we search CFNgoat, we can see Metahertz CFNgoat right there. And then which branch do we want to trigger this on? Let's trigger it on the master branch. That'd be main if your repo is newer, but this repo is quite old. We've been building it for quite a long time, so the repo name is still master for the main branch. And so at that point, we can move on to what do we want this pipeline to do when it receives an event. And in this case, the event is, hey, something's changed on the master branch of this repo. So you can see that what we can do is just go, okay, well, we want to trigger CodeBuild, and it will find all the different CodeBuild options. So we only have one CodeBuild build, so we'll select that. And what do we want to do? We want to do a single build. And now not only can you do your build steps like that, but you can see we can then build this up. what would we want to do after this build? Either, well, if it passed, if it fails, do nothing, but what would we want to do if the build passed? And this is the power of code pipeline, because then you can say, hey, actually, I want to kick off like a CloudFormation deployment. And because CFNGoat is CloudFormation, this would then allow us to automatically roll that new version of CloudFormation into our environment, and AWS would take care of the rest for us. But because we don't want to deploy it anyway, because we want to show that this will fail because we're stopping vulnerable things getting into our environment, we're going to skip the deploy stage and just build a really simple pipeline. So we can click Create Pipeline. And then that is ready. So if we go back to CodeBuild very quickly, and you can actually get there from within Code Pipeline by just expanding build, we'll see that we kicked this off earlier, and we reran this now that we'd fixed our permission issue with IAM. I'm going to kick this off again because we should be seeing some information. But again, remember, we hit this manually. We had to click Start Build here. And you can see this is now build number, let's have a look. This is build number 4. So now we have Code Pipeline configured. If we all go back to the fork we made of CFNGoat, we can actually make simple changes without having to clone our fork and mess around with IDEs and things like that. So we can very easily go into cfngoat.yaml, and we can click Edit. And let's just change, I don't know, let's just change the instance type of this EC2 instance from T2 Nano to T2 Medium. Like that. We'll give it a commit reason, change instance size, and we'll commit directly into the master branch. And what we're going to see when we do that is in Code Pipeline, if we go and have a look at our pipelines, that is automatically going to have noticed that change. That's the new git commit. We can see our commit name, so we've changed the instance size, and that's automatically going to started a new build. So if we go to build, we can see that in here, 4 that we just ran failed, and 5 automatically started because of our automation from Code Pipeline. So let's go and look at 4 first. You can see that we ran this manually, and now it is working because the API key is valid. And we'll also be able to see that in Bridgecrew if we go into incidents. And we can actually filter on incidents based on source. So we can see that we had the original scans from our CLI, but we also now have this AWS account number and Bridgecrew tutorial, which is our CodeBuild pipeline. So that is our CodeBuild pipeline automatically reporting the data from the pipeline in, and we can filter just on that and see the same things we would see when we ran it manually, but in an automated way. We can also go into the code reviews page where we'll see each of these step by step. So if you want to look, for example, here we go. If we want to look at the Bridgecrew tutorial pipeline and we want to look at just that run that happened at this time, we can dive down into just that version. We can see it's coming from Code Pipeline with the logo here. We can see the account name. And then what we're seeing is a load of really useful information and a single view of that single pipeline. Question from Jason on, is the reason we prefer to use GitHub for your repository? Nope, not at all. We support so many different Source control repos, if we go into integrations, you can see here, oh, by the way, notice now we actually have a new Bridgecrew tutorial integration because it knows we're getting this data from CodeBuild. If we click integration here, you can see in terms of code repos, pick your favorite, GitHub, Bitbucket, GitHub Server, Azure, GitLab. We automatically integrate, as I said, with all the different CI/CD systems and a couple of different IDEs. So yeah, no particular reason. Bridgecrew happens to be a GitHub-based infrastructure for our source control, but you know, your choice on that one, really. So there we go. We've automated checking that the pipeline will trigger automatically when we make a change, and that basically allows us to block our CI/CD pipeline if there are any issues, and also have a central view of those issues in the Bridgecrew platform. And we can kind of track those issues over time. We can, you know, generate PCI and other SOC 2 compliance reports based on this data automatically within the platform. And yeah, in a nutshell, like that allows us to be sure that we are only pushing secure infrastructure as code options to our cloud. So as we can see, these will always fail because there are issues, which is what we want, because the next part of the pipeline would be the deploy stage, and we don't want to deploy things like that. So how do we deal with things that maybe will never get to our production CI/CD pipeline? How do we give developers even more information? Let's say we run a multi-team effort where we have pull requests or merge requests for GitLab or GitHub or GitLab coming into our repo, maybe even from the public. Maybe we run like an open source infrastructure. And we have these pull requests coming in all the time. What do we do about that? And so for that, and again, you'll see a theme here that Bridgecrew cares about basically taking as many snapshots and as many measurement points for your security as possible. So right from running VS Code or running Checkoff on the command line, which can report into Bridgecrew, we now have infrastructure as code in CI/CD pipelines reporting into Bridgecrew. We can also take other points as well. And one point is pull requests. So to do pull requests or merge request scanning, which is super useful, we can go back to, again, this is all in the workshop. We are at 5.6. And what we can do is integrate GitHub directly for scanning pull requests or merge requests, or GitLab directly for scanning pull requests and merge requests. So 5.6, by the way, for people saying, why are you using GitHub versus other source control? Equally, we know that some people will already have CI/CD pipelines configured in other CI/CD tools. We're not expecting you to run a separate CI/CD pipeline just for Checkoff. We support a load of different CI, as you saw from the integration page. So if you did want to integrate a GitHub action to do the build we've just seen in Code Pipeline, we do have a page on that. I'm not going to go through it, but we have a page on that on 5.6 here. So what we're now going to do is look at, okay, the pipeline allows us to block the build. We might want to do things like automatically scan PRs as well. But this brings us into a really interesting topic, which is, okay, I know I have problems. What do I do with them? And so Bridgecrew does actually offer the ability to automatically fix certain misconfigurations. And the way we do that is by suggesting fixes when we know there is a fix to suggest, like, hey, actually, if you add this bit of CloudFormation or you add this bit of Terraform, it will fix the problem that you're seeing as a security issue. And we can suggest those automatically for you. However, in a CI/CD pipeline, where would we be suggesting those is part of the problem, because if we are dynamically altering your code as part of your CI/CD pipeline, you no longer know what is being deployed into production, because Git should be your source control, should be your source of truth. So we cannot really deploy automatically fixes in your CI/CD pipeline because they'd never make it back into Git. CI/CD is after the commit has been made. So the way we deal with that for fixes is through integrating directly with the Git repo itself. And so if we've already kind of looked through some of the results, so I'm going to skip 6.1 because we've already covered it. But if we look at 6.2, integrating directly with GitHub or GitLab, for example, what this is going to allow us to do, if we go back to integrations and we click add integration and we click GitHub, which says not installed, we can choose to authenticate to our organization. And at that point, it will, so go ahead and do this. So go into integrate GitHub, click on choose GitHub organization, which will pop up with a GitHub page. I'm just going to click continue there because I didn't want it to integrate with Bridgecrew because I'd need single sign-on and all kinds of other stuff. I just want it to integrate with my personal Git repo. Here we go. And I'm going to, you might have a different pop-up again, giving permission. This is going to redirect us back to Bridgecrew with permission to access GitHub directly. And what this is going to allow us to do, and I'm going to say, okay, which repos do I want to be scanned? So I'm going to go CFNgoat. And also for funsies, I'm going to go TerraGoat as well, just so we get some more data in the dashboard. But you just select CFNgoat because that's the one we forked. And so what we then have is, if we give it a second or refresh integrations, we then have GitHub directly integrated as well, or will be when it finishes and does its first scan. And so what we'll see is another source in, we'll see another source in the filter down here. So we'll see Metahertz CFNgoat, so directly from Git. There we go. That's my direct Git integration. But also that's going to enable us to do some really interesting things on some of these errors, because now we have a direct way of talking directly to our Git repo, not through CI. We actually have access to the source of truth. So let's, for example, have a look at this issue with object versioning needs to be enabled. We shouldn't ever not know if an attacker or someone accidentally has changed an object in an S3 bucket. So we should have S3 versioning enabled. It's a high severity because it breaks PCI DSS compliance. It breaks FedRAMP compliance. So this is a pretty serious thing that we need to have enabled for our S3 buckets. If I now click on this issue, we can see that this is reported repeatedly. We can see it's reported through our original scan via Checkoff on the command line. We can see it's been blocked by our CI/CD pipeline in CodeBuild and CodePipeline. But if I click on these, I can't click fix because I'd be changing code somewhere that isn't savable in a pipeline or in a single run scan in the CLI. However, if I click on a GitHub integrated error of the same issue, you see suddenly the fix button is available. And what this is going to do is it's actually going to suggest to me how I can fix that problem. So if we have a look at this and we have a look at its dependencies, show me the fix. And you see we have a couple of other buckets here as well. It's actually going to give us a pull request. So let's fix a couple of them. Let's fix that one and that one, because we have 3 buckets that have this problem. If I click fix, it's going to open 2 pull requests directly to my repo to automatically suggest how we solve that problem for these S3 buckets. So the next time that CloudFormation gets deployed, we don't have this issue. So we can see it's remediating. Try that again. We expected a success message there. Let's go and have a quick look at our repo. And you can see here, we've got that fix as a pull request automatically opened by Bridgecrew, which is saying, hey, Bridgecrew's created this automatically. These are the resources. These are the 2 buckets that have a problem. The PR is designed to fix these problems, and you can go and look at the details of those problems directly in the Bridgecrew dashboard and where it's flagging up. And then you can see we have a commit here. And you can see we are dynamically adding into the CloudFormation, enabling the option to turn on versioning. And so if we merge that into our CI pipeline, so I just go back here and go, yeah, let's merge that into master. That looks good to me. Thanks, Bridgecrew. You know, you've saved me some time researching that problem. So I've merged that into master. Now, obviously, merging into master is going to cause, you can see because I press remediate twice, we've ended up with 2 of those pull requests, but I've already merged one, so I won't merge the same one because it'd be pointless. So you can see we've merged that pull request from Bridgecrew in, and because we've merged that pull request in, it's automatically going to kick off a code pipeline job because it's noticed a change. So if we go and have a look at code pipeline, you can see it's immediately in progress. So we can see it's noticed that we've made this change. It's got the commit message of the merged pull request. Great. And therefore it will be running a code build process. So we can go and have a look at this in CodeBuild. And we don't need to stare at the CI/CD pipeline. But what's important is this will still fail because there are still other issues in the CFNGoat repo. But what we will find is the issues we were seeing here. So you can already see the issue has gone. There's only data bucket left from a Git repo scanning perspective. The other 2 have gone because we know that they have now, the scan has already occurred and it's gone, yeah, those 2 issues for those 2 buckets still now no longer exists in Git. But because we now have Git integrated, because we now have CI integrated, we will start to see those issues disappear as it goes through the CI/CD pipeline as well. So if I just refresh this, as that pipeline runs, we'll give it a second and come back to it, but we will notice that those issues for the 2 buckets we patched just start disappearing from all these different sensor points. And that's the whole point of the Bridgecrew platform. We're really trying to show that you need to not just check your repo, you need to not just block on CI, but you need to kind of make sure that you can see that fix. Is the fix just in Git, or did that fix make it through CI to fix the problem, and did it eventually make it into production? So if we refresh that again, we should see that when the code build pipeline is finished, it's still running. That's why. There we go, it's failed. So we'll start to see those issues disappear from this listing because we can see that they are no longer erroring in the pipeline. So the other benefit you get that I was talking about earlier from direct GitHub integration is, let's say that someone raises a pull request against your repo that contains problems. We don't need to allow third parties access to our CI/CD pipeline. Again, with the recent issues with people abusing CI/CD pipelines to inject their own code or extract secrets, even GitHub's kind of restricted running pipelines automatically for unknown authors submitting pull requests. So Bridgecrew tackles this in a different way. I'm just going to show you an example from another repo instead of wasting time creating a pull request. But you can see here we have a pull request into a TerraGoat repo, so into some Terraform in this case. And what it does is it adds a new AWS bucket, and that AWS bucket it's public, it's not encrypted, it does not have access logs, and it doesn't have versioning. By default, we were trying to create a vulnerable pull request. And you can see that in that pull request, before it's merged, before any CI is run, Bridgecrew automatically annotates those same issues you'd see on the incident page, or the same issues you'd see from CI, directly into the Git pull request itself. And we can do this for GitLab merge requests as well. And we directly annotate this so that any engineer looking at this pull request is going to go, no, I'm not going to merge that. It's a public bucket. There's a critical issue. That is not something we want to merge. Whereas, if you don't have a security advocate or a security team constantly looking at your pull requests that kind of specializes in CI and in infrastructure as code, this might have been missed. So again, really useful information directly where the developer kind of needs it most. So that's the benefits on two sides of the GitHub direct integration through pull request scanning, and also automating fixes through pull requests, which we've just demonstrated and merged. And then the final piece is, okay, but what about resources that I already have running in my AWS account from before we started using infrastructure as code? What does that look like? What's the posture of my actual things running in production? And for that, as you can imagine, we've injected ourselves into as much of the different parts of the developer process as we can: CI, Git, pull requests, running on the CLI itself. We also support runtime scanning against the same set of policies. So again, through the integrations page, you can see we've now built quite a set of integrations during this 2-hour workshop. And we can add a final one, which is the AWS cloud provider. And we simply click that. And there's 2 levels of access. So read access requires the most minimal set of permissions for Bridgecrew to access your AWS account. Read only, just metadata. So we can start looking at the configuration of your cloud objects and work out if they're violating any policies. The remediation stack actually does allow fixes in the same way as we do with Git, but directly into your runtime environment. And that's for very specialist use cases. For example, fixing brownfield deployments that don't have any infrastructure as code to fix in Git. You might want to choose AWS remediation, but we're going to go read only for now. And we're going to just click launch stack. This is going to redirect us to AWS automatically. And it's going to use a bit of CloudFormation to automatically integrate Bridgecrew into that AWS account. So we get this quick create stack page. We leave all the numbers as they are. We click I acknowledge and we click create stack. And what that's going to do is that's going to, as I say, run a bit of CloudFormation to do a quick integration to Bridgecrew. Goes and creates a really locked down read-only role, cross-account role, which allows Bridgecrew scanners to access the account and pull the data it needs. And we can see the create is complete. And then back in Bridgecrew, if we go and look at integrations, we can see the AWS account with read access only is now in progress for its first scan as an integration. By the way, if you want to delete any of these integrations, there's a delete button down the side. Next to where it says when they were added. And so what you will start seeing is issues directly from runtime starting to appear in your dashboard. You can see we have the AWS account, not the pipeline in the AWS account, the actual AWS account number itself directly there. And we can filter just on that. And we'll start seeing, as that scan progresses, we'll start seeing things appear in there. And so you'd know if, there we go. So here we go, we can see, let's just make sure I didn't I refreshed the page, so I overwrote those, my apologies. I'm gonna save that as the default for now, the default filter. And here we go. So do not use default settings of a VPC. Let's have a look at the guidelines for that. The default VPC is logically isolated, but the default settings of a VPC are not suitable. So you should be using your own VPCs and not the default VPC. Again, it's a PCI DSS 3.2 recommendation. So the level is info or low severity, but you can see pretty much every resource by default in our account is in the default VPC. So that's just warning us of that. And that's the first thing we found so far. Let's have a quick refresh. Hey, how's it going?
Well, hello. I have a listener question. So how do these runtime scans interface with something like AWS organizations? Maybe you have a bunch of accounts that you're looking to scan. How does the Bridgecrew platform connect with that?
Sure. So they're kind of doing, at the moment, you kind of have to integrate each account separately into Bridgecrew. Bridgecrew has kind of a model where you can create teams and add users to a particular Bridgecrew organization. And obviously within an organization, you can see everything that you can see on the dashboard. So yeah, at the moment we integrate each individual account. I'd say they're pretty complementary. You know, obviously you can kind of enforce security on both sides, but the reason we really from Bridgecrew care about runtime access is everything we do in Bridgecrew is to enforce good infrastructure as code security. And we can't fully say we're doing that unless we can see what does and doesn't end up in runtime. So, you know, we want to be able to compare runtime against the same set of policies. So probably slightly different use cases on why you'd want to do organizations than integrate Bridgecrew, but complementary in terms of you know, running a secure ship.
Definitely. Thanks, Matt.
No worries. And so another cool thing about having the runtime integration, as you can see now, we're starting to see, obviously these are kind of non-hardened, completely new AWS accounts that we're just using for this workshop. So, you know, if this was something production, you would probably have enabled a metric filter and alarm for anyone using the root or the main admin account. Same with an alarm for any IAM policy changes, you know, all this good practice for creating secure AWS environments. We found a code pipeline bucket that doesn't have the restrict public bucket set to true, all that good stuff. So, you know, if you're in a brownfield environment, someone once called it a golden field environment to me, but no, if you're not using infrastructure as code, I'm still going to call it brownfield. Then, you know, this could be super useful just to see what you already have running in this environment. And resource inventory is also going to allow you to dig into what runtime environments you actually have. It will show you any tags on resources. And yeah, especially if you have an older environment with a load of non-infrastructure as code stuff, this is going to allow you to kind of just, not from a security perspective, but it's just going to allow you to dig into what you have running in your AWS account as a useful little feature. So that's runtime scanning, and that just kind of completes the picture of from code all the way through to cloud. As I said, you can also do runtime remediation if you enabled that other integration, and it works in the same way. You click remediate, and it will tell you what it's going to go and do, but it is going to go and edit settings directly on those AWS resources instead of submitting a pull request if you're running infrastructure as code. And if you want to give that a try while you still have access to the account, by all means, go ahead and do that after the workshop. That's in 6.5. Now, the last thing I want to talk about before we wrap up is super cool in terms of the fact that we have access to the code. We can security scan your infrastructure as code. We can also security scan the configuration of your cloud objects. But a lot of people struggle with, okay, how do I know which object? Like, sure, if I'm the dev team, I am running kind of Terraform apply or deploying CloudFormation every day. I know which VMs or which instances of Kubernetes or S3 buckets I'm creating because I'm the one that's debugging them and I'm going back and forward between them. But in terms of like a whole organization visibility, how do I know which piece of code, which piece of infrastructure as code actually created a particular cloud resource? When did it create it? What git commit, what version of that infrastructure as code was last, used to create this resource in the cloud? And this is why we've enabled tracing as part of Bridgecrew, because the ability to understand where things are and what has been created from your code base is just as important to security as the policies themselves. So this is why we created an open source tool, which is now fully tied into the Bridgecrew platform, just like Checkoff, called Your. Your is another Star Trek character that could travel between different places in time and space. And with a company name, product name like Bridgecrew, you can understand why Checkoff and Your might be the names we chose. But the idea with Your is it enables code to cloud tracing. And it basically does that by understanding how to automate tagging of all of your CloudFormation or Terraform objects. So I'll give an example. And again, feel free to follow through this in the workshop afterwards if you want to understand a bit more about this. But if we go and find a smaller repo, just so it's easier to understand. So I've created a tiny, I've created a tinier version of CFNGoat and TerraGoat called DeployableGoat. And the idea with this is it's not got as many really bad vulnerabilities in it, and it's just kind of a little bit easier to look at and understand. So let me find my Cloud9 workshop. And if I go and clone this, you can do this yourself or just watch along at this point. If I go and have a look at DeployableGoat, in fact, we can just open it here in the IDE. You will see it's got a much smaller subset of, in this case, Terraform, but it's just got some S3 buckets. There's just 3 S3 buckets to make it a lot easier to see what we're looking at. And if I run Your against this, by just running Your tag -d, very similar commands to Checkoff in terms of just -d dot will recursively scan a directory. What this is going to do is it's going to automatically use the Git data from this repo. And it's going to, as you can see there, it's going to automatically populate each of our objects with tags. So we now have, you can see a tag for this object was last changed on this commit. It's in this file, which we know from here, but when this object becomes a real S3 bucket, we'd lose that information unless it was in these tags. It was last edited by this user. It last came from the DeployableGoat Git repo. And then we also put this UUID in here. And Your's clever enough to know that changes to its own tags do not constitute a change to the resource itself. So these will update if I edit something up here, but they won't update just by the fact that the tags themselves have updated, if that makes sense. So obviously I can then add those to my Git repo. And in fact, Your is designed to run in your CI/CD system alongside Checkoff. So it will automatically tag and commit those tags for you, so that if you then deployed this to AWS, which I guess we could try. Very cool that the Cloud9 environment already has the Terraform binary installed as well, you'll notice. So we didn't need to go and install Terraform. And because the Cloud9 environment has access to our AWS keys, we didn't need to configure security or anything like that. So what it's basically saying here is, let's go and create these 3 buckets. So I can click Terraform apply here. And this is why we're using deployable Goat rather than CFN. We don't want all those really bad security issues appearing in a real AWS account because of the shared responsibility model. Even in a demo, it's just not a good idea. So we're just creating 3 slightly insecure S3 buckets, which aren't going to open the account up to any particular harm. And so what we've done is we've done a simple deployment of 3 S3 buckets. But now if we go and look in AWS at S3, we can see the 3 buckets that we've just deployed via Terraform. But if we go into properties, we now have all these useful tags. Now, obviously, I've just deployed it, so these aren't useful for me. But imagine someone coming into Bridgecrew who has integrated the runtime scanning, and he finds in the runtime scanning, these buckets are alerting as part of the S3 policy, saying, hey, like they won't have showed up just yet. By the way, there is an API to force a rescan of the runtime environment if you want to. You can see the last time the scan happened. So it won't have, this allows you to know whether you should be seeing that data or not yet. But imagine, obviously, like we already have for the 1 S3 bucket, someone is investigating those 3 S3 buckets that have just appeared because Bridgecrew is highlighting that, hey, they're insecure. And I am not the person that has deployed those. I don't know anything about those. Using your tagging as part of our CI/CD pipeline, it literally allows me to go, okay, I know nothing about this bucket. I don't know who deployed it, where it's from, which dev team deployed it. But if I'm working for the same organization, I can literally take your trace or the specific Git commit, which will be unique across the whole of your Git infrastructure. And I can go, okay, let me just search the whole of, for example, GitHub in this case, for that commit. And there will be one commit across the whole of GitHub. And I have immediately found exactly where that was created. I have gone from a resource I know that my company needs to do something about, back to the exact piece of code and the exact version of the code that created that resource. I can see the author, I know who it is, I know when it happened. And so that tracing is super, super useful for all security incident response, and for also just kind of tying runtime and build time together in a really easy user experience. And again, there's more data on how to do that. And you can follow through this yourself, and also on how you would integrate into your CI/CD pipeline to automatically keep those tags up to date for you, so you don't even need to worry about manually doing the your command that I just ran. And then, as I've just shown, we can then use Resource Explorer, or we can go and find those things in AWS ourselves to find the commit and the ID, and how to immediately then find that back in Git. And we've documented all of that as well, if you want to follow through with that for yourself. And at that point, we are out of time. And I know we have a couple of competition-based goodies for people that stick with us. Thank you so much for your time. Thank you to Michael and the AWS team for all your support as usual. And yeah, any questions? We have a Slack channel for all things codified security. It's at slack.bridgecrew.io. Come and hang out with us, talk to us about this workshop, ask us questions if you're trying to implement some of this yourself. And yeah, thanks for your time, everyone.